Hello and welcome to another episode of Data Lounge, where we take a more relaxed and fun approach to data. We have with us today Bryn Burton. Bryn, thank you very much for joining us.
Hello everyone.
Yeah. How are you doing?
Yeah, good, thank you.
Glad to have you here. Yeah. What are we going to be talking about today?
So what we're going to talk about today is Cosmos DB. So I've been spending probably about the last year and a half of my life working on a very large project.
That's a lot.
With Cosmos DB, yeah. So, well, on and off. But yeah, so I want to talk today about the ins and outs of Cosmos DB, and particularly how data, how Databricks can be used with Cosmos DB.
Okay,
to kind of give you the sort of tool suite that you sort of miss from a traditional sort of relational type database that you might be used to with something like SQL Server and things like that. So I'm going to start off with a very brief overview of Cosmos DB, what it is, but I haven't really got time to go into detail of what Cosmos DB is and all that sort of stuff. That's not what the session is. It's talk about very specifically Databricks and Cosmos DB.
The interaction between Cosmos DB and Databricks, correct?
Yeah, exactly.
Brilliant.
Cool. So just to start then, what is Cosmos DB? So it's exactly as it says at the top there. So it's a globally distributed, massively scalable, multi-model database service. And what does that mean? So what it means is Microsoft have put in all the infrastructure in Azure to provide a very scalable, high transaction OLTP type architecture to support that type of system. So what they've then done is stuck a number of different database models on top of that underlying infrastructure in Azure. So to kind of take away all that complexity of setting up that infrastructure and then give developers tools that they're used to and the tools that most suit the particular application you're building, sitting on top of that infrastructure. So when I say there's kind of multi-models, there's kind of 4 different types of database that sit on there. So you've got key value pairs. So that's kind of if you want a very quick lookup, kind of look up a value, look up a key, get a value, and a thing. There's then a typical column family type thing. So it's just similar to storage tables were before in Azure Storage. So if you want typical database tables of data to use, then you can use Cosmos for that. There's then a bunch of JSON documents, which is the one I'm going to be focusing on today. And that is storing a list of JSON documents in Cosmos DB. And that works really well with web type applications when you're calling APIs or microservices where you're kind of sending around little bits of data or updating little bits of data and stuff like that. Kind of keep it as JSON documents. And then lastly, there's a graph type structure. So that's kind of if you want to map relationships and things like that. So say you want to kind of map relationships between customers and complex things, or a typical kind of graph structure would be something like LinkedIn, which use kind of all the different relationships of how you do stuff. So sitting on top of these 4 models, you then have a number of APIs. So I've got quite a lot there. There's actually more now as well. So the idea of that is developers can then use the things they're typically used to. So something like MongoDB is an open source, well-known thing for dealing with documents. And then SQL is the one I'm going to be doing today, which is pretty much the old document DB in Azure. So it gives you a kind of an interface on top of a set of JSON documents.
Interesting. So we're going to be using SQL to query those JSON documents, correct?
Yeah.
So, perfect.
Cool. Okay. So if I kind of briefly talk about how Cosmos DB works, a very brief thing, and explain why Databricks works so well with it and stuff. So at its simplest, Cosmos DB is a 10 gig store of JSON documents. So it's a single database, and that's pretty much what you got with Document DB before Cosmos came along. So you store those documents in there.
So the size is predefined already. It's 10 gigabytes always.
Yeah, exactly.
Perfect.
So what you typically have is a process of some sort. So maybe an Azure function or a website or something talking to that database. So that's kind of nice and simple. But how does that then scale in a Cosmos DB world? So rather than making that 10 database bigger, it shards the data out.
Oh.
So what you have is multiple 10 gigabyte databases, and they actually kind of behave quite separately in a way. They're kind of, the framework sits on top of them and allows you to kind of join them together to a certain respect, but you have to kind of think of them as separate databases.
Okay.
That's the other thing. And that works really well in a high transaction LTP type scenario, because you've got lots of little individual parallel processes, each ideally hitting one of those individual databases that are in there.
Okay.
And that's kind of really Cosmos' sweet spot. So it likes lots of small transactions that are fast and doing that type of thing.
Interesting.
So being Altius, generally, yes, we can design systems to update all these small transactions, but generally where our focus is data. And generally once we've got the data in there, we want to get the data out and do something with it.
Yes, normally that's what we want to do, correct.
Yeah, exactly. So when we get it out, typically how you get data out of a database, you might have some sort of ETL type scenario or something like that, and you might have a big processor sitting here. And you can do this type of pattern, so where you have one process going to all those databases. And you can do that, and it can work, but it's a little bit clunky. So you have to kind of go across all those databases and things like that. So ideally what you want is something similar to Cosmos' sweet spot. Lots of individual processors hitting each of these individual databases as it goes in that thing. And that's where Databricks comes in. So Databricks, it sits on top of a bit of technology called Spark. And Spark is a massive parallel big data processing engine. So quite a good fit for what we want to do. We want to do stuff in parallel and we want to do stuff. So the way Spark works and Databricks is we have a head node, and that will do kind of all the controlling of your query. So you send a query, it goes off to the head node. And what that head node then does is splits it into a number of different parallel tasks. So it will take a particular query and say, right, what is the best way of splitting up that query into different bits? And then it will run them on individual CPUs within a cluster of machines in Azure. So it's quite a nice, easy way to create a simple query that then parallelizes
and then
out.
parallelizes. For our viewers and those of you watching this, probably this head node is the same driver node, right? It's the same driver node, and each one of those small ones, additional ones, those are the worker nodes, correct?
Yeah, exactly.
Okay, good.
So that then, going back to the same pattern, works really well with Cosmos. So Databricks can interrogate Cosmos at that level and fire off loads of parallel queries, grab the data from each of individual databases and then pull them back together. So that's why the two work really well together.
Perfect.
So you're pleased to know that's the end of the slides.
Good.
We'll go straight into some demos and see what you can kind of do with these two technologies.
Let's take a look.
So Cosmos DB, as I said, sits in Azure. So we have an instance of Cosmos DB you can create. We generally script them, but you can, with a few button clicks, create a Cosmos DB instance. And in this particular example, I have a SQL version of it. So what it is a bunch of JSON documents sitting in Cosmos. So when I was doing this demo, the projects I've been working on is focused on customer data, so I couldn't really demo that. So I looked around for some data, JSON type example data to find. And a good example I found was data.police.uk, and they have a bunch of APIs, which are quite nice, and they return lists of JSON objects, which I thought was ideal.
Good.
So what I actually did is created a Databricks notebook, and I connected to these APIs, I pulled the data down, and I inserted them into Cosmos. So I'm not going to demo that today, but that's how I kind of got the data in there. So as you can see, if you're kind of used to a typical SQL-style database, you'll notice straight away that the difference here is the data is not sitting in tables, it's lumps of JSON sitting in there. So each one of these items here is a set of JSON.
Good.
And you have properties and values, and you can have more complex structures. You can have kind of sub-objects, you can have lists of objects within objects and stuff like that. And that worked very well for the project I was working on because it was kind of customer data and there was kind of quite complex kind of a list of addresses or alternate first names like nicknames and things like that and stuff. So that kind of works quite well within a
because it's not necessarily a well predefined schema, right? It's something that can vary, because when we're talking about more of a relational database approach, we need to make sure that every row has the same number of columns and the same columns, actually. But here, not necessarily.
No, exactly. So, what this gives you is just a really nice flexible structure, and you can add additional properties if you want as well, which works quite well. So, in this system I was working on, we had numerous different kind of feeds of data about that customer coming in, and all of them had slightly different sets of properties and stuff that we want to map in. So mapping them into a JSON structure worked a lot better than kind of having more of a flat table type structure. So you don't end up with lots of kind of null columns sitting there.
Null columns all over the place.
So Cosmos DB internally has a simple query language. So it is similar to SQL. So this is a query. I can right click on my collection and I can query this. So if I want to count here, I can do select. It's slightly different to SQL. You have to put the word value in for some reason. And that will give me a count of objects. So you can see here I've loaded in 120,000 stopped search records from the police.uk website. So the actual data subject doesn't really matter. It's just the fact I've got sets of JSON sitting in here. So this language is quite nice, and you can obviously query the documents, but it's limited. So you can see here I have multiple collections of documents in here, and I can query within one of those collections using this language. But I can't, for example, join two collections together.
So here in Cosmos DB, even though we're using SQL, we cannot do join operations.
Yeah, exactly.
Not left join, not right join, those things don't
so you can't really do that. So there is a join clause in the SQL, but that's more for, say you have an object with a collection of objects within it, you use a join to kind of flatten out that object. So you kind of join that to the sub-collection. But you cannot join documents together, and you can't join collections together within Cosmos. You also can't update within this language. So
there is no update clause
either. There's a select, but there's no update. So again, kind of we're looking for something different where we can do that type of stuff. So that's where Databricks comes in. So this is Databricks. So again, in Azure, I spin up a cluster. So it's all based on PaaS technology. And what I get is this user interface, which is the Databricks user interface. So the first thing we have is a cluster. So you can see here we have 3 nodes I've configured of certain size VMs to do this particular demo. So you can have obviously much larger clusters if you want to do bigger things, but that's more than enough for my demo. So the first thing you need to do for Cosmos DB is install a custom library. So we have a Cosmos DB library.
That library does not come with Databricks, or it comes with Databricks, or do we need to download it? How do we get that library?
So it doesn't come from Databricks by default. So the way you get it, if you go onto this GitHub site, this is a kind of Microsoft run GitHub repository that's open source. And they have built this Cosmos DB connector for Apache Spark. So the easiest way to install it is using Maven coordinates. And Maven, if you're kind of familiar with .NET, is similar to a kind of a nugget. So it's a kind of packaging framework and stuff like that. So you get a path to that library. And all you have to do in here is just click New, you click Maven, stick in the path, install, you're done.
And that's it. And with that, then we have the libraries required for Databricks to actually connect to Cosmos. Good.
So once we've got that, we then have workspaces. So workspaces are kind of built on top of a Jupyter Notebook style interface. So you have a workspace. You can see here I'm on my user, and I have built a number of demo notebooks to do this particular thing. So if I start with querying as a demo. So what I've done is attached this notebook to the cluster, my default cluster, and that means I can then run it. So when I want to connect to Cosmos, what I first need is where is Cosmos and what's the key to actually access that Cosmos. So I put them in Key Vault. Azure Key Vault, and nice and secure, hidden away on the thing, and I use this dbutils.secrets.get to get those items out of Key Vault.
From Key Vault to get it out, and that's it.
I then create something called a read config,
Okay.
which I pass in that URI and key. I then say what Cosmos database I want to access.
Okay.
And then I say what collection I want to access. And then I can pass in a custom query. I can just return that entire collection.
And the entire collection. Okay, good.
So what I'm doing here is a nice simple query, select top 1,000 all from that collection.
Okay.
So if I run that.
Good.
So what that's doing now is it's just getting an execution context. It's just kind of warming up. It should be quicker once it's actually connected.
Okay.
Hopefully.
And right now, so of course, right now, because all that connection information was within Key Vault, what we're doing with this is actually going to Key Vault, getting that information out, and establishing a connection.
Yeah,
correct.
Exactly.
And part of that connection can either be bring the whole collection, is that it? Yes, to bring all the collection, or we can actually run a query already to bring us some set of data.
Yeah,
right?
exactly.
Okay.
So what it's doing here is getting an execution context, which is what Databricks does straight away. So there we go, it's finally done it. So generally, if you haven't used it for half an hour or so, then it just has to set up that execution context again.
Okay.
So it's now done that. It took 3.8 seconds to kind of do that particular thing. So the next thing I do is load it into a data frame. So if you're in Spark and you're dealing with data, you put data into a data frame. So it's kind of like a table in a database that you put stuff into. So what I'm doing here is using that SDK, the old library I've installed, which is the Spark library, and I pass in my read config object, and I just say load, and that's all I have to do to load that into the data frame. So that's now loaded in. You can see that's running.
Trying to run now. Okay,
and
good.
It's now done. So it hasn't actually loaded any data in yet. All it's kind of done is set up the metadata to do that particular thing.
Good.
So everything I've done so far is in a language called Python, which is one of a few different languages I can use within Databricks, which is kind of quite a popular language, data scientists, etc.
Yes, a lot of the data scientists we work with on a day-to-day basis, they seem to be very, very fluent on Python. It's like their natural language for them, right?
So you can also use things like Scala, Java, different types of languages, or R is another one that you can use. So if I want to switch languages, because I quite like SQL, I can do this thing called create or replace a temporary view. And what that does is it kind of puts a bit of metadata in the underlying Hive store that kind of sits in Spark.
Okay.
And by doing that, I can then sort of switch the context to a different language and do that. So I can't pass a variable from Python to another language because it doesn't really understand it. But by sticking a bit of metadata in a separate Hive store and then pulling it back out again, I can swap languages. So I've now created that view.
Good.
And now I can do a count. So little test view, Alejandro. So I'm selecting a top 1,000 out of this thing, and I'm then doing select count from that. So what would you expect that to return as a?
That should be 1,000.
Yeah, well done. So let's see if you are right. So that's running, and it's come up with 4,000.
How?
So,
don't change my transact SQL knowledge now.
So why has that happened? So if I look down in here, what I can do is actually drill into what this Spark job's done, which is quite a nice feature of Databricks. And I can see here the first clue here is 4 out of 4.
Yes.
Thing. And if I click on this little info icon here, I can then go down here and I can see the head node here, and then I can actually see these individual worker nodes.
Yes.
Which we were kind of talking about earlier. And you can see here it's done 4 different worker nodes. So it's actually split them over 4 different items as it goes through. So why has it done that? This particular cluster has about 16 cores, I think. So it's not limits of the cluster or anything like that. So to understand that, we need to kind of look at Cosmos underneath and see what that looks like. So this here, I'm looking at the Cosmos DB metrics. And if I go into storage and choose my particular collection I'm interested in, which is the stop search collection, I can now see, if that loads, that it's split over 4 different physical partitions.
Oh, okay.
And this is actually a particularly bad example of how not to store the data in Cosmos. So
because there is a lot more data on the first one than in the other 3, correct?
So the reason for that is I quite quickly dump this data in from this API, and I partition the data. So I tell it how to partition the data, and I chose, the police force as the thing. But when you look at this data, metropolitan, fairly obviously, has far higher than everything else. So actually, what I probably want to do is actually look at this and go, right, what's a better field to partition that data with?
Good
stuff. So, but you can see here that it's actually, we've got loads of logical partitions, but it's physically put that into 4 of those shards. And Databricks has managed to interrogate it at that level and understand that there's actually 4, and each individual processor hits one of those physical things.
So this integration between, and this is absolutely interesting, this integration between Databricks and Cosmos. So Databricks is smart enough to ask Cosmos how many partitions of data you have, so that Databricks / Spark can actually trigger that number of partitions and align based, similar to try to achieve the approach that we were showing on the slides, right? One processor querying a set of data.
If I use like .NET, I couldn't do that. All I can do is work at logical partition level. So Databricks interrogates at a lower level, which is really
useful. That's really powerful.
So it kind of hits in. So that's why we get 4,000, because it's a select top 1,000 at each individual shard.
For each individual,
You obviously have to just bear that in mind of when you're using it, if you're doing a count or something.
Good.
So let's go for something slightly more complicated. So a group by with a count by false. So how many things we got in there. So if I run that, that's now sent back a list of counts by false. Nothing rocket science there. I could put it into a chart if I wanted using Databricks and stuff as well. So then, with something like JSON, it's not like a table type structure. So you have properties and you have nested properties within JSON.
Correct.
Stuff like that. So if I query this, I can see here I have object as search, and I can see location is kind of a nested set of properties within a more kind of complex object. So if I do something like this, what I can do is do location dot street dot name, location dot latitude, etc. And then I can quite easily just flatten that out into.
Wow, this is great, because normally when you think about it as a data person, right? If you think about interacting with JSON type documents, you immediately start thinking about, I need to start writing code to program. You don't think that you really could work with a SQL-ish flavor, particularly in this kind of environment.
And now it's in a more kind of standard table type format, and I can use that in something like Power BI or something like that in a much simpler way. And similarly with arrays, so if I just load in a slightly different collection, so I've downloaded information about the forces, so just each of the different police forces across the UK from another API. And in here, what this has is the name of the force and something called engagement methods, which if I just quickly run that, you can see here we have a number of different ways you can engage with the police force.
And this definitely looks
Facebook,
more
Twitter,
complex,
etc. So what I've got here is an array within each of my objects and stuff. So if I want to do that, I could use the join statement in Cosmos DB, and I could flatten it out, or I can use something called explode in thing. So there's a number of kind of functions I can use in Databricks to actually kind of explode that data out. So by doing explode engagement methods, it's now done a row per item in that array for Nottinghamshire, for example. And then if I want to just kind of flatten it out slightly further, I could do, put that into a CT, so you can do common table expressions, etc. as well, and then flatten that out. And now I have.
It's great that we have this concept of CT here, definitely, because it's something that if we work with Azure SQL Data Warehouse, with Azure Azure Synapse, it's something that we are very familiar with.
Exactly, and that's the beauty of using Databricks and Spark. Spark is pretty much as feature-rich as something you get in SQL, whereas Cosmos DB SQL isn't.
It's a little bit more limited.
Do a lot with it. So then, very quickly, joining. So again, if I have 2 collections of data, I can't join that in Cosmos.
Yes, correct.
So if I want to do that, I can pull in 2 tables. So I just do 2 read configs. In one case, I'm selecting top 1,000. The other case, I'm just saying grab the whole collection.
The whole collection.
And what I've got here is stop search, and then I've got some details about the people in each police force, so the main senior people that they published on their thing. So again, I'll load that into 2 data frames this time. So I have my stop search data frame, and then I have another data frame, people.
Okay, and it's exactly the same pattern that we were using in the previous example. Okay.
And then once I've got them in data frames, in a similar way, put them into 2 views. So I've done display data frame here, just so we can see what that people data set looks like. So you can see it's got the person's name, a biography, some contact details, etc.
Okay, good.
And then if I go down, I can use a magic spark, and then I can join them together in exactly the same way as you would join 2 tables together. So what I'm doing here is stop search join on false ID equals false ID, and I want to find all the chief constable ranks and stick the chief constable's name against each of those stop search things and do a count. So how many counts by chief constable, name, etc. And as you can see there,
very
it's
straightforward.
now joined that together. And what that's done is fired off those 2, set of queries to Cosmos to both collections, pulled it all back in memory, joined it all back out, and spat it out.
And give us the result. Okay.
So
that's really, really interesting. Yes, it's much more straightforward.
Yeah.
Anything else you want to share with us today, Bryn?
I think, if I just very quickly go through updating, because I think this is probably one of the most useful parts.
Yes, because you mentioned there is no update. There is select, but there is no update.
And that's one of the most useful things I found with Databricks.
Okay.
So if I just jump back quickly to here, if I look at this people collection.
Yes.
Say, in this particular one, this is kind of where, I've got kind of a more flexible type interface. So I've got here a false Twitter feed property here.
Okay.
So I've got that in that one. So maybe if I click on this one, or this one here maybe, one of them doesn't have it. Find it in a minute. There we go.
Isn't it? Yeah.
So this one doesn't have it. So this kind of shows some of the flexibility. Property's not there.
Yeah.
Let's add it in. So I can do that manually. I can go in there. I can just paste that in there. I can update, and that's now updated that particular thing. So one of the advantages of Cosmos DB, it's very flexible. I can just add in additional properties.
And that's it.
And things
just
like that.
Live, just like that.
Yeah.
Okay.
But if I say wanted to add Twitter feeds for all of my objects, I've got 200,000 in there. I don't want to do
might
that
take a while on the copy paste.
So, and as I said, there's no update statement in Cosmos DB. So I could write a .NET application to do that, and I actually did that in my project. It was about 1,000 lines of .NET to kind of completely, when we went from phase 1 to phase 2, we sort of refactored the way all the documents were in the Cosmos database, and we had to pull them all out with .NET, manipulate all of those documents one by one, and save them back in to kind of change the shape of those documents and stuff.
Okay.
That was before I found Databricks.
The part of Databricks, okay.
So what I can do here is I can pull out that similar set of data. So what I'm running here is I'm using a Cosmos DB function called isDefined. So what I'm saying is give me all the objects where false Twitter feed is not defined already.
Okay, but it doesn't exist basically, right? Exactly. Right? For that element does not exist within the JSON document.
So so what I can then do, so I run that, I again similarly put that into a data frame.
Okay.
And then what I got is a kind of Parquet file sitting in the data lake. So it's nothing to do with Cosmos DB at all. And what this has in it are a list of falses with Twitter feeds. So the Twitter feeds for those falses.
Okay.
So what I can then do is, because I've got that into a data frame now, with people, I can join to that thing. So I'm now joining Cosmos to a file in the data lake. So
wow.
Different technologies joining across them. Put that into a view. And then if I just, again, in a similar way, put that back into a data frame, so I can then use it in Python again. I can then kind of review that, and I can see now I've got false Twitter feed added there on that particular thing. And then to write back to Cosmos, I literally simply do, in a similar way to a read config, just a write config. So I give it the endpoint, the database. I give it something, a writing batch size. So I set this to 100, so you can optimize that in different ways.
Yes.
There's an option to upsert or overwrite. So if you've got documents in there, you can either overwrite them in there. And if I run that, that will then go off and update Cosmos DB.
And that's it, with only that?
Yeah, so that's now done.
Wow.
If I go back, it should now have Twitter feeds for a lot of these different things. So assuming they've got one in there. So
let's see.
Yeah, don't know, but they should be in there. So Yeah, so you've
There
got
we
full
go.
Twitter feeds, for
Yeah.
South Wales, for, So
there.
I don't think there was necessarily Twitter feeds in
All
that
of them,
complete list
yeah.
of all of them. So,
But it was very straightforward to have
Yeah.
to write back to that Cosmos DB. Definitely, it's very powerful because it's like
exactly.
it's what I see from this is that we're data people, not necessarily we're very fluent on Python. Right?
Yeah.
If you're a data scientist or the users are or the technical people is more from a data science background, Python is very natural to them.
Exactly.
But for us, probably more traditional data-oriented people, TransactSQL is much more straightforward, and this is very straightforward.
And I've run out of time, but in terms of re-partitioning that collection of objects, again, in a very similar way, I could take all of those objects, take them out, add a column on that's a different partition key, and then insert them back into another collection, and then I've sorted out that partition issue that I showed you earlier on the thing. So all of these type of things you can use Databricks for with Cosmos.
Very, very powerful. So thank you very much, Rin. This was really, really great. Much less scary than I thought it was going to be. So much more straightforward.
Yep.
Thank you for that. Thank you for being with us today. And to all of our viewers, thank you very much for having joined us in one more episode of Data Lounge. Don't forget to subscribe right down there because Laura from marketing likes people. So if you can subscribe, that'd be great if you love the content. And once again, thank you very much. Hope you have a fantastic day. Thank you until next time.